Hi guys, so we are down to the last two problem sets. We're only going to teach lesson 36 and lesson 37, and then next week we're going to work on a couple of worksheets to make sure you understand the concepts we've learned and prepare for our finals. Believe it or not, we're almost at the end. Today we're going to be focusing on problem set 36, and I have written on the board Geo number 2 and 30. Okay, so I'm going to move just a little bit so y'all can see better. There you go. That way I can at least see you while I'm teaching. Okay, and I have written on the board, the title is Distribution Property of Rational Expressions. Now, a rational expression is the expressions we have been studying where we have a ratio as a fraction. So remember that ratio is basically compared to things. So a rational expression is an expression that is in a rational format. Now, on the board, I have written mx over 4y times ax over 2y. Now, before we get to that, let's consider if I were to write on the board 2/3 times 5 over 7. The rules for multiplying fractions state that you multiply the numerator, so I'm going to write it down here, and you multiply the denominator, which is 21. And then, of course, you simplify when you can. In this case, I cannot, so I leave it as 10 over 21. And we know that all of the rules that apply to numbers also apply to variables. So if I can multiply the numerators and the denominators to find a solution, then I can do the same thing to my variables. So I'm going to go ahead and take my expression on the left, and I'm going to multiply using those rules. So I'm going to say mx times ax. Now, I'm going to put this in alphabetical order, so the A, M, and notice I have x1, x2, and I know that when the bases are the same, I add, so I get amx squared on the numerator. If I follow the same logic going on the denominator, I'm going to multiply the coefficients. I'm going to get 4 times 2 is 8. I'm going to add 1 and 1. I'm going to get 1 squared. Then I'm going to take a look, and I have amx squared over 8y squared. And I notice that they do not have anything in common. There's no y's up here and no m's or x's down here. And the coefficient is already reduced. So that is it. I do not have to do anything else. Just as always, don't leave a 1 as a coefficient and don't leave 1 as an exponent. As long as you do this, then you are done. Okay, so there is my solution. So let's apply that rule using the distributive property. Now, the distributive property allows us to multiply the coefficient to the inside. So if I change this just to an x, and I change those just to a minus b, I know my solution would be ax minus bx, because I would multiply x times a and then b times x. Okay? So the same logic will follow if I add a denominator. So I'm going to fix that again. A over y minus b, and then I'm going to have x over y as a coefficient. So the easiest way to think about this is to split this, okay? Split it. Think of only the numerator and only the denominators. Since this doesn't have a denominator, it's helpful to put a 1, okay? Now I'm going to split that, and I'm going to say equals x a minus b, there's the numerator, over y, parentheses, y minus 1. Now I have taken the numerators and put them in the top, and the denominators and put them on the bottom. Now it'll be easier to see how I'm supposed to distribute. Okay, focus only in the numerator, and you're going to get a times x, negative b times x is negative bx, over x times y minus 1 times x. So y. So minus y. Now notice if I didn't put the 1 here, then it looks like you don't do anything with the y. It's blank. But if you put the 1 there, it makes it easier to see that you actually have to multiply the 1 times the y to get negative y. Now let me verify that just to be sure that I didn't make a mistake. And yes, that is right. So you end up with ax over xy minus bx over y. Now you can simply take off the sign, and the only thing is when you do it this way, I need to make sure, actually I did this wrong because the 1 is not negative, it's up here. So that should have been plus 1, which makes this a plus y, okay? Which we know that a negative times a positive equals a negative, so you don't need the positive here. You just leave it as ax minus bx over xy. Oh, I'm sorry, it should be read ax over xy minus bx over y, okay? So basically the rules that apply to numbers apply to variables. So to multiply a rational expression, you multiply the numerators, add the like terms, so you add the exponents, you multiply the coefficient, and then you add the exponents. To distribute, you can split it as a fraction, and then you're going to multiply the numerators, so ax, and then bx, okay, on the top, xy on the bottom, and y on the second fraction. So that is how you use that property. Now let's look at another example, okay? So I'm going to do, let's see, let's look at 36.2, because that one looks a little bit difficult. So let's look at that. 36.2 says it's going to be m over z, okay, times axp over mk minus 2m4p4, okay? Let me make sure I copied that right, mz, and then I have axp over mk minus 2m4p to the fourth. Okay, so following the logic that I had before, I'm gonna split this, so I'm gonna create two fractions, okay? I'm gonna put a 1 in as a denominator, and then I'm gonna see that the m is only being multiplied to the top, so I'm gonna rewrite this as maxp minus, sorry, hold on a second, yeah, minus 2m to the fourth, p to the fourth, okay? That's my numerator. Then I'm gonna write one denominator, and I'm gonna say z m k, and then remember that this is a positive 1, not a negative, over 1. And then close your parentheses, okay? The next thing I'm going to do is I'm going to go ahead and I'm going to distribute, okay? So I'm going to say m times axp, I'm going to do it over here. It's going to be ampx. Again, I'm just putting it in alphabetical order. If you don't do that, you're not going to get it wrong. It's just it makes it a little bit easier to keep everything straight, okay? So I'm going to do ampx, okay? And then you got to do the second term, so minus 2m. Now I'm going to add a 1 because I have another m here, so 4 plus 1 would be m5, and then p to the fourth, okay? Now the numerator's done. Now I'm going to do the denominator. Notice I split the two lines just so I can have two different fractions, okay? Do it again on the denominator. So zmk would be mkz, and then 1 times z would be z. So your answer is ampx over mkz minus 2m5p4. Now the 2 and the z look similar, so please be clear. You can either write this 2 like that so that it's clear. Make sure that you don't confuse that, because then you're going to think they're like terms. The last step, just like with any fraction, if you had 2 over 4, you know that that's not reduced. You would have to say 1/2, right? So you have to do the same thing. You have to look and say, oh, okay, well, the m's cancel out. M over m would be 1, just like 2 over 2 would be 1. So those cancel. Okay, you're left with k, z on the bottom, and there's nothing else in the first term that's similar. So a, p, x is left on top, k, z is left on the bottom. Okay, now let's look at the second term. You have 2m5p4 over z. Well, they have nothing in common. so you don't need to reduce the second term. So 2m5 p4 over z. Again, those look the same, so I'm going to change that. There we go. And this is your answer. Now let me verify that again, because sometimes I do make mistakes here. So we have apx kz over 2m to the 5th p to the 4th z. Yes, that is correct. Okay, so that is how you use this particular property. Now I need to go over the second concept, so I'm going to pause the video and pick it up.